Hi, my name is Technetium-99m. I'm a second-year physics student from Bilkent University. Today, I will be explaining my PHYS-212 project, which is the approximation to half-life of Technetium-99m by using Geiger counter. To understand our project and the working principle of the Geiger counter, we first need to know about radiation. Radiation is generally meaning that the energy that is carried out by waves or particles, and this energy produced in nuclear reactions. There are three main types of radiation, and they are alpha, beta, and gamma. In our project, we will be using Technetium-99m, which is producing gamma radiation, so we will be dealing with it. Radioactive particles, which is Technetium-99m in our project, produce a different amount of radiation per time. That is called radioactivity. And there is a concept said half-life that indicates the time that is needed the particle to be half as radioactive as the initial value. In our project, we tried to estimate the half-life of Technetium-99m by using its radioactivity levels at different times. In order to do so, we use a Geiger counter in our project. The working principle of the Geiger counter is depending on the Geiger Müller tube that is inside of it. The tube is filled with gas. And when this gas is affected by the radiation, it starts to let the electron flow for a moment. At this instantaneous moment, the circuit starts and works, and an high double click tones is created at that time. By the digital Geiger counters, these click tones can be counted and the average radioactivity level can be calculated. In our project, we constructed and used a Geiger counter that is consisting of three main elements. They were a Geiger module, an Arduino engine, and the LCD screen for displaying the results. Due to safety concerns, we have conducted our experiment in Hacettepe University. There, we have calculated the radioactivity levels of the Technetium-99m with intervals of 30 minutes for 30 seconds. While the Geiger counter is working and the radioactive material is there, we have recorded the video in order to be able to analyze the data later on. The data found in these experiments was shown in this graph. The lines in this graph are representing the results that is found in 3 minutes intervals, and the dotted lines are representing the mean values at that times. When we look at the data for the mean values of the radioactivity, we can see that there is an obvious decrease in the radioactivity levels with time. But the problem is that we were expecting an exponential decay that was coming from the equations about radioactivity. For the approximation of the half-life of Technetium-99m, we used the data that we have found. For calculation, we used two main general formula, and then we have created a formula by using them for our purpose. By using this formula, we created a computer code that can automatically calculate the approximate half-life for us with the given data. And then by compressing the approximate half-lives by data, it gives us an average value. The average value is comparable to the expectation, which is 6 hours. Our value was 205 minutes, while the expectation was 360 minutes. Our findings are including some of the legitimate data, but they also include erroneous and problematic data too. First of all, when we investigate the graph for the mean values of the radioactivities of Technetium-99m with time, we can see an obvious decrease with time. That was totally expected. But the problem is, we were expecting an exponential decay in the results. However, this was impossible to examine from this graph, and these results are not seem like an exponential decay. The problem is probably caused by the lackness of data. because we know that the graph may have changed its behavior during the interval that was chosen. And due to restrictions, we have not able to include lots of data. Besides that, the problems might have been caused by the inabilities of the Geiger counter that is working with the Geiger tube, and it has its problems too. And when we investigate the results for the approximation of half-life for the Technetium-99m, we can see that the error percentage is very high. The percentage is 43m, and this value could not be disregarded so easily. However, the value is not totally illogical, and it can be comparable to the real expectations of the half-life. The problem in this part is probably again occurred due to the lackness of data. Also, the Geiger counter might have caused some of the problems, because its working principle is depending on Geiger tube, and the Geiger tube is most including problems with gamma rays. As a conclusion, we have found data that is similar to expected results. Even though our results are not totally accurate, they were not totally irrelevant too. Also, we were able to manage to use our knowledge about radiation successfully in that project. Thank you so much for listening to me.